Hello, everybody. We are going to start with section 1.2, Exponents and Radicals. So take notes. So again, the homework assignments on the calendar that are marked in red mean that you actually don't have an assignment on Pearson's web assign. You'll have it on a PowerPoint file that I will include in Canvas. Okay, so take notes. Okay, so 1.2, exponents and radicals. So chapter 1 should be review, but I don't know how long it's been since some of you guys have taken a math class. So it's always good to review. Okay, so exponents and radicals. Let's start off with the notation. Okay, so here, if we have something that looks like this, exponential form, so then here, this number n is the exponent. And this here, a, would represent the base. Okay? And when we use exponents, it's important that you understand what it means. Okay, so if you have something like a to the n, then it means a times a times a times a. Okay, and that means it repeats in times. Okay, so for example, if you have 2 to the 5th power, then this means 2 times 2 times 2 times 2 times 2. This does not mean 10. This does not mean 2 times 5. Okay, so because here we already see 2 times 2 is 4, and then times 2 is 8, times 2 is 16, times 32. Okay, I mean equals 32. Okay, we got that because, again, 2 times 2 is 4, and then times 2 is 8, times 2 is 16, times 2 is 32. Okay, let's take a look at what the 0 and the negative exponent mean. Okay. All right, so if a is a real number, a is not 0, a is going to be the base. Okay. And n is a positive, so it's not negative, integer, then we have the following two. So if you have some base, again, a is not 0, and you raise it to the 0 power, so whether that base is 2 or 5 or 7, 2 to the 0, 5 to the 0 power, 7 to the 0 power, doesn't matter what that base is so long as it's not 0, it equals 1. Okay. And then the other thing is that if you have some number, again, not 0, and you raise it to a negative exponent, okay, so now you have a negative exponent there, then here we get the reciprocal. So when you take the reciprocal, then that exponent becomes positive. Okay. All right, so for example, we'll do a few. let's go ahead and simplify each of these. So number 1, if you have this fraction 4 over 7 to the 0 power, again, you have that 0 power, so this fraction raised to the 0 power should equal what? 1. So if you said 1, you are correct. Okay, if we have this x raised to the negative 1 power, so again here, we look at the rules for negative exponent, we see here that if you have a negative exponent, then you take the reciprocal. So here you would get 1 over x to the first. Since it's x to the first, then we don't have to write the exponent. X is the same as x to the first. Okay, if we have this one here, negative 2, that's the base. And we're going to raise that base to the negative 3. So again, if that exponent, negative 3, since it's negative, if it's negative, then we take the reciprocal, 1 over the negative 2, and it's the exponent that becomes positive. Okay? And then we would go ahead and work that out. What's negative 2 times negative 2 times negative 2? That would be 1 over negative 8. Okay? And it's negative 8 because we have negative 2 repeated 3 times, right? Times negative 2 times negative 2. And here, negative times negative is positive. And here we get negative 8. Okay. All right. And let's suppose that we already have it like this, and this x has a negative exponent. Okay. So again, you just take the reciprocal of this, and taking the reciprocal of this will bring that x back to the top, and the exponent will become positive. Okay. And so let's take a look at some of these. So if I have m to the negative 2 on top, and suppose that I have n to the negative 3 on the bottom. Okay, so since they both have a negative exponent, then they are both going to move. We're going to take the reciprocal of each one. So the m has a negative exponent, so it will go to the bottom. Okay. That's a little messy. Let's go back. Okay, and then the letter n on the bottom has a negative exponent, so it will need to move up here. Okay. Okay, so if they have negative exponents, then they will essentially move. Okay. Okay, so let's take a look at the laws of exponents. Okay, so we have a law for when you're multiplying like bases. So if you're doing this base, it can be any base, times same base, different exponent. Okay, so if you're multiplying like bases, do you remember what we do with the exponents? What do we do? Okay, if you said you add the exponents, that is correct. Okay, so I'll do an example over here. So if you have 2 to the third times 2 squared, this is going to be 2 to the, add the exponents, and we get 5. 5 is correct. Okay, same thing with division. So we have a law for division. Okay, so if you are dividing like bases, do you remember what we do with the exponents? We subtract them. That is correct if you said that. Okay, all right, so for example, if I have 2 to the 5th up here and 2 squared down here, then I get 2 to the 5 subtract 2 is 3. Okay. I like to subtract from the bigger exponent. So let's suppose that we have this instead. Okay, you can still do 2 minus 5 if you want to, but over here, I like to subtract from the larger exponent. So from down here, 5 subtract 2 is 3. And I'll get that. Okay. And I'll explain why in a second. I'll explain both of these. But let's finish up the laws. We have this third one. If you have an exponent and you have this raised to another exponent, then what do we do with the exponents? Multiply. Okay, so for example, if I have 2 to the third raised to the second, so I have this power to a power, so we multiply and we get 6. Okay. All right, so let's go back to the first two and let's take a look at why we get these answers. Okay. That's supposed to say why. Let me. Okay, so let's take a look at that first law. Okay, suppose that I have x to the 4th times x to the 7th. Okay, so we already know by the law that it's x to the 11th power, right? Let's take a look at why. All right, so x to the 4th times x to the 7th. Okay, so let's write down what x to the 4th means. X to the 4th means x times x times x times x. It repeats 4 times, right? X to the 7th means that it repeats 7 times. So there's 1, 2, 3, 4, 5, 6, and 7. So 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7. Okay, so here we just have this long string of repeated multiplication. We have a total of 11 of them. So again, repeated multiplication can be rewritten with exponents. So this repeated multiplication of x can be rewritten as x to the 11th. And so we see here 7 plus 4 equals 11. Okay. And then same thing with dividing like bases. Okay. So if I have y to the 4th times, oops, here we go. Hold on a second. We're doing the second one. Okay, so if I have y to the 4th over y to the 7th. Okay, so this here is like saying y 4 times, and down here y 7 times. Okay, and we can see here that, okay, well, these two will cancel, these two will cancel, these two will cancel. There's a bit of a delay in my ink here. And those will cancel, leaving us with 1 on top and y cubed on the bottom. Okay, so we see here that it's basically canceling 4 y's with 4 y's on the bottom, leaving you with 3. Okay. All right, let's take a look at some more examples. Suppose that I have this b to the 4th power raised to the 5th power. So here, according to our rules, we would multiply our exponents 4 times 5, which will give us 20. And then over here, if I have this as my base, 3x raised to the 3rd power, then this here, we have 2 things here, as opposed to the top example, b to the 4th, there's just 1 element in there. Here we have 2. We have the 3 and the x. And since they are in parentheses, then they will all get their exponents multiplied. So in this top one, we see that it has an exponent of 4. Over here, we don't see any exponents, but if you don't see any exponents, the exponent is understood to be 1. Okay, so no exponents, understood to be 1. Okay, so if you have to multiply, then we would get 3 to the 3rd power and x to the 3rd power. Okay, and this would essentially be 27 x to the 3rd. Okay. Okay, there's one particular problem that students kind of have difficulty with no matter what every single year. Okay, so I want to kind of pay extra attention to this type of problem. Let's take a look at this problem. -2 raised to the 4th power versus -2 raised to the 4th power. Okay, so in the first one over here, because we have these grouping symbols, the base here would be what? -2. Okay, so it's the -2 that would get repeated 4 times. So this would mean -2 times -2 times -2 times -2. Okay, and when we multiply this out, we will end up with, if we do these two, that's 4, that's +4, 4 times 4, that's 16. Okay, so we end up with +16 in this first example. Now, if we take a look at this next example, here we do not have grouping symbols, so here the base, the number that will get that repeated multiplication, is not -2, but +2. So over here, the negative gets brought down, okay, but it's only the 2 that gets repeated. Do you see the difference? Okay, in which case here, the answer will be -16. Okay, so just make sure that you know the difference between these two. Make sure you understand that this one here in particular, uh, the base does not include the negative. Okay, let's take a look at simplifying expressions. Okay, hope. Okay, so somebody is walking by screaming obscenities. I hope you don't hear that. The joys of living in Long Beach. All right, 2a cubed b squared times 3ab4 all raised to the third. Okay, so a lot of times students are like, oh, how do we even begin with this? I always like to, if there are exponents on the outside like that, I always like to start with those. Okay, so I'm going to bring this part down. Okay, and then this one, all of the exponents inside here will get multiplied by 3. And again, no exponent means an exponent of 1. So this one will get 3 to the third. This one will be a to the third. And this one will be b to the 12th. Okay, multiply all the exponents. All right, so, and then here, hopefully, that's 27. Okay. All right, so 2 times 27 is 54. Okay, and we're just multiplying here. So since I'm multiplying like bases, I add the exponents. So I'm going to get a to the 6th. And then same thing here. B squared and B12 is going to be b to the 14th. Okay, so that would be the final answer. So again, how should you start? If you have any exponents out there, that's how I would start. Okay, let's take a look at another one. Suppose that I have this, x over y to the third, and over here, suppose I have y squared x over z raised to the 4th. Okay, so again, you have those exponents on the outside, so I would deal with them first. These guys in here have, you don't see an exponent, so it's understood to be 1. So these guys are going to get x to the third and y to the third. And then these guys over here, the y becomes 8 there. This becomes 4. And this one down below, z to the 4th. Okay, so once you've taken care of those outside exponents, then you can go ahead and you can do your multiplication or your division. Doesn't matter which order, you'll still get the same answer. So multiplying like bases across the top, I get x cubed times x to the 4th. So I add the exponents and I get 7. And then over here, I get y8. And then down here, I get y to the third and z to the 4th. And now I can do my law for the division, in which case I cancel my exponents. So y3 will cancel out with 3 from the 8. So I get x7 here, and I get y to the 5th here. And nothing happens really with the z. You get z to the 4th on the bottom. Okay. And you know you're simplified if you don't have any negative exponents and you only have one of each base. So if you had an x here on top and then another one somewhere else, you're not done. Okay. One of each base and all positive exponents. Okay, so let's take a look at laws of exponents if you have negative. Okay, so they're basically the same, but so I was talking about this here earlier. If you have negative exponent, right, then you take the reciprocal and then the exponent becomes positive. And we looked at an example of letter B here. So letter B here says if you have something like this, if they both have a negative exponent, then they essentially swap places and their exponents become positive. Okay. Okay, let's simplify this one. Six st to the negative 4 over 2 s to the negative 2 t squared. Okay. All right, so let's start off with the numbers. 6 divided by 2 is 3. So 3 in the numerator. I like to move all the ones that have negative exponents. So this one can stay. The t to the negative 4 can move to the bottom, becomes positive 4. The s negative 2 move to the top, becomes positive 2. And the t squared, that can stay. Okay. And then from here, now I can do my multiplication of like bases. So then 3 stays, and this becomes s to the 3rd power. Because remember, when we have like bases, we add the exponents. And then down below, we have t to the 6th power. Okay. So that would be the final answer. Let's take a look at another one. Suppose that we want to simplify this one. Y over 3z cubed all to the negative 2. Okay. So different ways to attempt this. So you could either multiply all the exponents inside by negative 2, or you can use the rule that we just saw where, oh, well, they all have a negative exponent too, so they're all going to flip. So let me use that one. So because this is negative right here, that means everybody inside here is going to flip. So 3 z cubed over y, and their exponent then becomes positive. Okay. And then now you can do each one on the inside. That will become 3 squared. Multiply the exponents z6 and y squared. Okay. And 3 squared is 9. Okay. So 9z6 over y squared. Okay. Something easy like 3 squared, yes, I will expect you to work out. If you get something like 5 to the 7th power, you can just leave it. Okay, so that's pretty much it for exponents. So we're going to do radicals now. Okay, so that's like square roots and cube roots. Okay, so radicals. All right, so if you see this, square root of a equals b, then that basically means that if you take that b and you square it, then that should equal the number a on the inside. And again, this is for b greater than or equal to 0. Because we're not, well, we'll get into negatives later. Okay. So if you have this square root of 9, hopefully you know what the answer is there. The square root of 9, the principal square root of 9 is going to be 3, because if you take that 3, according to the statement above, if you take that 3 and you square it, you should get 9, and we do. Okay. So when you're taking square roots, you're trying to find a number that when you square it, you get the one on the inside. Okay. So the nth root in general. Okay, so the nth root in general, if n is any positive integer, then the principal square root of a is defined as such. Okay, so if you're taking the nth root of a and it equals b, then that essentially means that b raised to that nth power should give you that number on the inside of the radical a. Okay. And if n even, it's an even number, then a is greater than or equal to 0, and b is greater than or equal to 0. Okay. All right, so let's take a look at some examples here. So, for example, if I'm taking not the square root, not the cube root, let's do the 4th root. So we need a 4 inside here. Okay, so we're taking the 4th root of 81. Okay, so we're trying to find a number. When you raise it to the 4th power, it gives you 81. So that would be 3. Okay. because when you take 3 and you raise it to the 4th power, you should get 81. Okay, let's do another one. Let's do cube root of -8. Okay, so we're trying to find a number so that when you raise that number, we're trying to find a number when you raise it to the 3rd power, we get, here, hold on a second. Let me do that over here. Okay, so you're trying to find, okay, you're trying to find a number so that when you raise it to the 3rd power, you get -8. Okay, so what number would that be that you raise to the 3rd power? Did you say -2? You are correct. Okay, so the answer would be -2. All right, so let's take a look at properties of roots. So this is probably going to be the only lecture that is this long. Okay, the other ones are pretty short. Okay, properties of nth roots. Okay, so this first one. Okay. All right, so we have this one here that says if you're taking the nth root of a product, you can break up that product. So you can split them up and take the nth root of each one individually. And, oops, I need the eraser. That's not supposed to be a B. Okay, so if you're taking the nth root of a product, you can break them up. So let me show you an example here. Cube root of -8 times 27. Okay, so -8 times 27. Okay, well, we notice that each one of those -8 and 27 are both perfect cubes already. So it's easier if we just take the cube root of each one individually rather than multiplying -8 with 27 and then trying to find the cube root. Okay, so here it's easier if we split them up and find the cube roots of them individually. So the cube root of -8 is -2, and the cube root of 27 would be 3, in which case here, the final answer would be -6. Okay? So again, it's easier to take the individual cube roots instead of multiplying -8 times 27, getting a big number, and then trying to figure out the cube root of that. Unless, of course, you have a calculator. All right, let's take a look at this one. So this property says that if you're taking the nth root of a quotient, same thing as the one above, you can split them up. Okay, so we can do the nth root of A divided by the nth root of B. Okay, so again, it might be easier to split them up because they're already perfect nth roots. So let's take a look at this example. So suppose that I have the 4th root of 16 over 81. Okay, so here again, these are perfect 4th roots. So let's go ahead and do each one individually. And we see here that the fourth root of 16 is going to be 2, and the fourth root of 81 is going to be 3. Okay. Okay, we have 2 more properties. All right, number 3. If you have this, a root inside of a root, okay, so what you can do is just take the product of those 2 roots, m and n, and just create one radical. Okay, so for example, suppose that I have this one here. Suppose I'm taking the square root of a cube root. Okay, so taking the square root of this cube root of 729. Okay, so instead of dealing with this double radical here, I could just multiply these 2 here, and that would be the 6th root. And now we have a single radical instead of 2. And we're taking the 6th root of 729, which equals to 3. Okay. All right, and then this last property, if you have the nth root of a to the n, okay, then we have 2 outcomes. Okay, so the first one, so if n is odd, then the answer here equals a. Okay, so if you're taking like the cube root or the 5th root or the 7th root, an odd root, okay, then you can just say, oh, the answer is a. Now, if n is even, so if you're taking like the square root or the 4th root or the 6th root, okay, so if n is even, then the answer to this is going to be the absolute value of a. That way we take the principal square root, which is the positive. Okay. All right, so for example, if you have cube root of -5 to the 3rd power, well, we're taking the cube root, which is an odd number, cube root, so this answer is just going to be -5. Okay. All right, if we're doing this 5th root, 2 to the 5th, again, 5th root, that's odd number, so the answer is just going to be 2. Okay. If we do something like this, let's do 4th root. Okay, 4th root of -3 to the 4th power. Okay, so here we're doing the even root, 4. Okay, so we have to do absolute value of this here, which is going to be 3. Okay, so whenever you're doing an even root, Okay, whenever you're doing that even root, you're going to need to do the absolute value. Okay. Okay, now let's take a look at simplifying. All right, so let's take a look at this example here. Suppose that I have cube root of x to the fourth. Different ways to go about this. If you learned a different method, that's perfectly fine. Whatever method you're comfortable with when you first learn these, that's fine. Okay. One way to approach this kind of problem is by taking this here and trying to write it with sets of exponents of 3. Okay, since the root that we're dealing with is a cube root. Okay, so that means that this x to the fourth can be rewritten as x to the third and x to the first, right? And then here we can use that property that says, oh, well, we can split them up. Okay, so here we can split them up. Oops, forgot my exponent there. Hold on, wrong place. Okay, so we have that there. So here, this first one simplifies to x, and the second radical does not simplify at all. Okay, so we will leave the second one. Okay, so again, this is just one way to simplify these. If you learn how to do this by dividing the 4 by the 3 and then the remainder remains inside, that's fine too. Whatever method. Okay, so here I'm using the method where you split this x to the 4 up using x to the third. Okay, let's take a look at another one. Suppose that I am using the fourth root. Okay, and I have 81 x to the eighth, y to the fourth. Okay, so again, I want to split these up using powers of 4. Okay, so 81 can be rewritten as 3 to the fourth. X to the eighth can be x to the fourth, x to the fourth, and we don't need any more. And then y to the fourth, well, that can just stay 4. Okay, so once you have as many powers of 4s as you can get, then you can break them up individually, or if you can skip that step as well, but if you need to see it, this is essentially what we're doing. Okay, and so here this first radical will give me 3. This next one will give me x. The third one will give me x. And the fourth one will give me y. Those two x's can be combined to make x squared. So the final answer here would be 3x squared. And remember, we're taking the even root, So I'm going to go ahead and put absolute value around the y. We don't have to do it around the 3 because 3 is already positive. We don't need to do it around the x squared because anything you square will be positive. This y, we don't know what y is, so whatever it is, it could be negative, it could be positive, we don't know. So we put the absolute value around y. If you're not sure, then just put it around the entire answer, okay? And again, you only do that when you're taking the even root. Okay, and hopefully you remember how to simplify something like this, square root of 18. 18 is not a perfect square. However, we can break it up as a product of a perfect square and something else. So here we can break up 18. So we can use 3 times 6 or 9 times 2. Which one do you think you would use and why? Okay, 3 times 6 or 9 times 2. Okay. If you said 9 times 2, that is correct. We would use 9 times 2. Okay. And the reason why we would use 9 times 2 and not this one, not 3 times 6, is because 3 and 6 are not perfect squares. However, between the 9 and the 2, the 9 is a perfect square. So you always want to use the one that has the perfect root. Okay. So here the final answer would be 3 square root 2. Okay. And then the other thing that you would need to do is also be able to combine radicals. So let's take a look at how we combine radicals. Okay, so for example here, hold on, I'm doing a lecture video. So over here, you have square root 32 plus the square root 200. So neither one of these are perfect squares. However, you do want to break down each one so that you do have a perfect square. So 32. And you want to try to take the largest perfect square. So maybe you don't see it. Maybe you're thinking 4 times 8 for the 32. That would work. If you use 4 times 8, okay, that would work. But then you have to also notice that here, this 8 can also be broken down using 4 times 2. Okay. So you need to just make sure that you break it down some more if you can. So over here, I'm going to use 16 times 2. Okay. And then that 2 can't be broken down anymore. And then over here, I'm going to use 100 times 2. Okay. So the 16 and the 100 are both perfect squares. So here, I'm going to get 4 times square root 2. And here I'm going to get 10 square root 2. Okay. And here, because they have the same radical, they both have square root 2, then these are like terms. So I can combine these, and by adding the numbers on the exterior, 10 and 4, so I get 14 square root 2. Okay. All right. So I think that's a good place to stop. So that pretty much covers 1.2. It's review. So you don't have an actual homework assignment on your WebAssign, on your Cengage WebAssign. I think I said Pearson accidentally earlier. So it's through Cengage. So you don't have an actual assignment for this, but there is a PowerPoint on Canvas where you can try just like 2 or 3 problems. Okay, just to make sure that you do understand it or that you do remember from way back when. All right. Thanks for watching. Again, if you have any questions, just text me through the Remind app or email me.